And we are going to use the spark this equipment to take a look at what lightning is, where it comes from, to put lightning safety to the test, and then to end this presentation by making the biggest indoor thunderstorm that happens anywhere on the planet. Sound good? Yeah. I can't turn the show down at all. There's not a volume knob, so I can't make it any more quiet or any louder than it is. If you or anyone you brought with you today doesn't really like bright flashes or loud noises, or perhaps more relevantly than that, happen to have a little one in a stroller, we do not recommend this presentation for children of those ages. You certainly know your kids better than I do, but if your little ones don't like bright flashes and loud noises, you're welcome to try to stay for the show, but if you do need to leave, don't feel bad, it happens all the time. Sound good? Alright, let's get started. The way the Van de Graaff generator works is very, very simple. Remember, the Van de Graaff generator is a big thing here in the center of the theater. It uses 3 conveyor belts to lift the electric charge from the room that I'm standing over up through that wooden column into the red and blue metal domes up top. You can see those conveyor belts on the video to the left and the right. They're yellow, there's 3 of them. And to make this machine work is wicked simple, as they say in Boston. We spin those conveyor belts at 60 miles an hour. When they're spinning, you can hear them. You can also physically see them up there in the video. Once those conveyor belts get up to speed, you put electric charge on them. The charge gets lifted from the basement to the top of the machine. Eventually, so much charge comes up, it goes through the air, and makes a spark. So at this point, I ask everybody sit back, relax, and I'd like to introduce all of you to what this machine does the best. What you just saw is a spark, but I'd like to start off our discussion of lightning and electricity with the idea that just because we saw a spark doesn't actually mean that we saw electricity. And to talk about why that is, I want to introduce you to these things. These are smaller, older cousins of the large coils to the left and the right. Now, given the fact that we just saw 8-foot-long lightning bolts, the sparks that these machines make are, quite frankly, not as impressive. So it might surprise you to learn that that spark is being produced by 50,000 volts of electricity. This is the reason why we don't use 50,000 volts to power our houses. If we did, we'd have that coming out of every plug in the wall of our house, and we couldn't have pets. So in our houses, we choose a voltage that may jump into the air and zap our ankles every time we walk by a plug. 110 volts works just fine. Voltage is a measurement of potential energy. The higher the voltage, for our purposes here in the theater, the bigger the spark. 50,000 volts gives us about a 3-inch spark. 500,000 volts gives us about a 5-foot spark. The big Tesla coils will make about 900,000 volts, which is a little bit. At the end of the show, we'll turn the Van de Graaff generator up to about 1 million. So as the voltage goes up, so does the spark size. One of the things you may have noticed about this presentation up until this point is, one, we talked about lightning, we talked about voltage, but I haven't said the magic word yet. And of course, the magic word is electricity. Right? We haven't actually talked about electricity at all during this presentation, and there's a reason for that. Lightning is caused by electricity, but it isn't electricity. You can't see electricity.